So I think you're familiar with this topic, how to lie with data and statistics. It's quite popular. There are a lot of books written about this. But I will explain further why I have chosen this topic. So first, who I am, and then I will ask you. So I'm a principal data scientist. I work with open data, also computer vision, IoT data, and high-performance compute. I moved from working with open source data to predict poverty, education, and health in developing world, to working with machine data, from mobile data, satellite images, and different sensor data within city environments. So this is about me. I want to know, who are you? So let me check. Can you show me how many data scientists are here? Okay. Data mining, big data people, architects. Okay. Business people. Oh, quite a few. Okay. I guess we all have a very different background. We're all calling ourselves data scientists. We come from computer vision, business analytics, mathematics, data engineering. So we are a very good mixture. I will be quite specific in the examples I'm giving. So that's why I wanted to check who are you. Machine vs. human-generated data. As I mentioned, lying with human data is very easy. It's highly objective, very biased. The process of asking the questions and collecting the data is not just biased, but there are no, I would say, proper ways of collecting the data. Therefore, I will not go in this direction, because we all know the experience of working with human, unstructured, weird data, from tweets, from behavior, from clickstream, from papers written from random people. So it's highly biased. Also, when communicating this data, visually, we can do a lot of tricks here and there. We can touch the questions in a way we want to prove our results. So we're all familiar with this. I was dealing with this on a daily basis when I was working with survey data. When I go to developing countries, let's say Albania, Georgia, or African countries, and you try to collect survey data to predict the poverty of the region. So when you ask the question, do you accept democracy, you get yes, and that's what we did. And then we realized the people had no idea what democracy is. So they answered yes, had no idea what they're saying yes to, and we analyzed the data based on it. We created the AGI models of the UN, and it was all wrong simply because we had no idea of the background of the people. So when I was done with it, I moved to machine data and said, okay, I'm done with wrong, biased, unready data. I'm moving to something very stable and linear with a very good structure or semi-structure. So I was quite happy to move to the IoT space. When I moved to the IoT space, there were a lot of frameworks to execute an IoT project. And I think most of you are familiar with this one. This is the CRISP methodology, which was developed by Harvard to execute a data science project. And those are the general steps of going through collecting the data, transforming it, modeling it, visualizing it, and then bringing it to the end user. And this applies for human data and for machine data as well. The transform model visualization, I will not touch, because those are the areas where I mentioned you can do false statement with visualization. You can trick the data so it proves your results. We're all familiar with this. I will try to show you some tricks when you try to plan and acquire the data in this process. So why machine data? When you try to gather information about people, behavior, telemetry data, environmental data, it's all information, and you need something to transfer this information to kind of a consumable insight for a computer. This happens only with Internet of Things, so all the sensors. It could be a small 1-cent sensor on your device, or it could be a big oil ring somewhere at a remote location. And the main idea is that you change the granularity of the prediction you are making in both cases. What is holding us from doing all of this, especially in the developing world? It's highly complex. So when I told the human data is complex and it's wrong, when I moved to machine data, to IoT data, I was so far away from the truth when I was thinking that it will be all clean pipelined and ready for me just to score my model on top of it. You have device hardware, which is very specific. There are no standards for it. You have device operating systems, which, again, have no standards. And each of those layers has its own bias, because some engineer applied it for a specific case. The function of those devices is that they work, but the main idea is that they should produce constant results. So you have networking, where the data is transferred. You have some ETLs, where the computing happens, and all the mobile and cloud environment of this IoT data pipelining. The architecture for the machine data: application, analytics, storage, event streaming pipeline, connectivity gateway, and devices. Each of those has its own biases. I will show you how it works with device and gateways, and it all needs the security layer. For each of those components, there is a price tag attached for executing this, so you need to make some assumptions and compromise the information you're transferring. So when you acquire the data, doesn't matter if it's human or machine data, you have the process of collecting the data. In our case, we are collecting it with sensors. Then we go to the cleaning data. We see things which do not fit our expectations, so we just get rid of them. We try to identify patterns to see how the data communicates, and then make prediction out of it. So we are trying to guess what will happen. If we will have a threshold or several, and then a failure will happen. Each of those processes, you bring your own assumptions, because there is no standard for it. The type of informations and the devices. This is just an example of some devices we use to collect data. We are not interested in the metastate and commons data, simply because then the price of transferring this information to a specific gateway or computing environment or data warehouse is very high. We're just interested in the telemetry data, the temperature, the vibrations, the thresholds within certain manufacturing environments, big cities, or isolated areas. Here is a summary of the different certificates which go to the cloud. And when you start with the asset and the beacon of attaching to a specific item to make the item smart, you apply an ETL or assumption, which is again wrong. Then access points, again, some engineer had configured it so that it transfers the minimum information for the price you have paid for this access point. And then the Wi-Fi router, again, with the starting point of having a temperature or vibration or human behavior from your health tracker on your hand, each of those steps reduce the amount of information till it gets to the end point. Because those sensors are still very expensive, some of them, the computational and the transferring power and the inference is also very expensive. So the truth starts here, the end result is something different. An example from everyone's life is sensors sometimes lie, and this is the first assumption. You all have all those Fitbit or whatever tracker you have, and you know that you're walking, you're running, and then you see certain behavior in this analytics, and you know it's not true. You know you're overperforming when you're simply just walking. And those are failures within the sensors or within the model of the application. Why it's important? In this case, it's not so critical. If you move to a place, isolated place, let's say an oil ring, where the price for the sensor is not that expensive, but price to change a sensor, which is already drilled down into the ground, and that's what we do, is very high. To send educated engineer who can do this, and to find that engineer on time so you don't lose production time is also very high. So this might be a failure or of the sensor, or might be a reality. In both cases, you need to react. If you pass on some of the failures and say, OK, this is not critical for me, it might happen that you simply didn't foresee a failure which can jeopardize your production environment. So when sensors sometimes lie, even when they're not lying, sensors don't always tell the whole truth. What I mean by this, imagine we are collecting behavior from a sensor, doesn't matter if it's a small or big one, and we gather certain thresholds. For us, it's important to predict when will be the next one. So we need to capture them. And it's important how we set those thresholds. Why they're not telling the whole truth? Because of the computing power and the price. They're all summarizing. You'll never get the reality. When you look and talk to the engineers, that's what they do, is they pre-configure different amount of sensors with different configurations which do not represent the truth. They just transfer the minimal information for you, so you are able to react on it. They do not have any standards how they summarize this. There is no corporate world who goes to them and say, OK, please make the granularity of the sensors very good, so we are able to capture it. It's basically manufacturing decision. And because the price is a leading factor, the lower the price is, the lower the information they transfer. So everything we get from machine data right now is highly summarized and, faulty. So let's say that we know about the failures of the sensors. We know that they summarize information. Now let's see what we do if we already have some sensor information. We have the raw data, and the data we have itself means nothing. So you need to apply to a context. You need to apply certain techniques, clean the data, try to detect the event. And in each of those steps, you are applying on top of the engineer's decision, your data science decision, how to summarize the process from your data side, from your data science side. Means you are applying another faulty layer on top of it. You're reducing the fact that you will detect an event failure or failure in general, or you will predict a failure with at least 15%. How you can check it? Check your own devices, your health trackers. When you are sleeping and when you wake up and stand up really fast, your blood pressure, and sometimes you have a headache, please check if the sensors on your device is collecting this information. Because itself, the sensors do not collect your physical or health status. They collect the proxies from your body, the temperature, the vibration, the speed, your specific location, are you lying, and they make assumptions on top of it. So someone did this assumption for you. So do not trust and always question those devices. This example is not very harming, but if you move to healthcare, where the patients are tracked with devices, or if you move to very expensive units, let's say in a manufacturing site, or from what we are doing in geospatial research, with the satellites who collect the images, failure of sensor is really important for us to capture and the information, simply because there's a really big price tag attached to it. In summary, in all of this combination, let's say that you're trying to predict the failure of an engine in a train, and you have the sensor data which is telling you that several thresholds were passed, so you need to take action on it. What action can you take just with the sensor data? You can't. You need the information of the destination of the train, so you need to connect different systems like CRM systems, supplier system, HR system. Why? Because you need to decide how far does it take for the train to get and how dangerous it is to let the train continue, because of reputational risk or because of health risk. Then, in this project, we had to mix CRM data to see if we have engineer in the closest network who can answer this request. The next question is, does this engineer can fix that issue? Does he have the qualification to do this? If yes, does he have the spare part? So we go to suppliers. This all needs to happen in around 5 minutes. We call it real time, but it's actually between 5 and 10 minutes for the decision to be taken. Then, if the person can change the part, can go to the location, how critical it is for the testing process and the train to continue to the final destination, and do we need to send another train? And this all needs to be communicated with middle management, where certain processes will be triggered based on this sensor data. By itself, sensor data is not very helpful. Some key takeaways. From my experience moving from human data to sensor data and machine data, highly shocked how faulty and unstructured and unrealistic it is. So sensors sometimes lie. Even when they're not lying, sensors do not tell the whole truth because they're summarizing a lot because of price and no standards in this area. Extracting useful insights requires multidimensional analytics, mixing with different data and different data sources, not just machine data. And yeah, by itself, sensors do not really tell a lot. You always need to apply certain context on top of it. My suggestion is don't try to be a general data scientist who can deal here and there with different problems. Try to be very specific either in security, in healthcare, retail, finance, because then really can do a difference and make a difference. Yeah. That's it. Thank you.